Raj, in this last video on functions, we're going to look at inverse functions. First of all, we're going to look at the rule in relation to the composite function, which we've seen already. Then we're going to use f of minus 1, this is how I say it, using algebra, the inverse function using algebra. And then we're going to graph a couple of functions in relation to the line y is equal to x, and we'll see the relationship between them. So firstly, the rule. So here's the rule of two functions. F and g are defined so that f of a goes to b and g of b goes to a. Then f of g of x, slightly different way than we've seen it written before, and g of f of x is equal to x. We say that f and g are inverse functions of each other. So that's the rule. It doesn't really come up in much detail. What does come up is using them, finding algebra and graphing them. So let's have a look at finding them, solving algebra. There's a couple of rules here that we need to follow, and they're really simple. Okay, Raj, let's have a look at these two. And we'll follow these 3 steps, and then maybe you do 1 or 2 yourself before we go on to the graph. So step 1, write as y equals. We start with f of x. Y is equal to 2x plus 3. Write x in terms of y. So we're going to get 2x is equal to y minus 3. So x is equal to y minus 3 divided by 2. Up here we were adding 3. Now we're taking 3 away from, dividing by 2, the opposite of multiplying by 2 up top here. And then step 3, replace. So we say that the inverse function f minus 1 is equal to x minus 3 over 2. You can see what happens here. The replace means that the y that we get down here gets replaced by x. And that's how we get our inverse function every single time. So let's look at doing the other one the same way. Y is equal to 12 minus 4x over 3. So 3y is equal to 12 minus 4x. Step 2, write x in terms of y. So we're going to get 4x is equal to 12 minus 3y. So x is equal to 12 minus 3y over 4. And then the replacement method, we would say that the inverse function g minus 1 of x is equal to 12 minus 3x over 4. The replacement that happens again is that when we solve down for y, it gets replaced down here with x. And this is how we write our inverse functions, step 1, step 2, and step 3. So now I want you to try 2. So Raj, if you'd pause the video and try these 2. Okay. Step 1, y equals 6x minus 4. In terms of x, 6x is equal to y plus 4. So x is equal to y plus 4 over 6. So the inverse function of h is equal to x plus 4 over 6. You have replaced the y with the x at the final stage. Similarly, Raj, y is equal to x squared plus 6. I'm sure you've identified at this point manipulation of formula is the key to this. In terms of x squared is equal to y minus 6. These have come up as these questions. Write the inverse function. X is going to be equal to the square root. It will be plus or minus the square root, and we're just going to get the plus version here. Y minus 6. So that will be the, unless we're given restrictions on this, we'd say the inverse function is going to be equal to, I should write the inverse function of x here, is equal to the square root of y minus 6, where we replace y with x, so it becomes x minus 6. Be careful not to forget that replacement at the last minute. Okay, let's have a look coupled with a fraction in it as well. So Raj, I'm going to challenge you to do this question 14. think as tough as they get. If you're asked to write the inverse of a function, remember all the steps, write them out. Step 1, step 2, step 3, bring them down into your copy, and then try this question here. Pause the video now, and what I'll say to you before you start it is, maybe with this guy, why kind of think about what they're saying to you here. The range is between 0 and 1. And then maybe bring that in at the end of the question. But when you don't understand, it's very hard to understand exactly what's going on here, but you do know the steps. What are the steps? Y is equal to, hopefully you've attempted it now, x squared over x squared plus 1. Now this is a funny one here. We need to write it in terms step 2, x is equal to, so we have to simplify this down as x is equal to. So what we can do here, we can write that y over 1 is equal to the right hand side. So then we can invert the fractions and say that 1 over y is equal to x squared plus 1 over x, which is the key to this question, I think, then. And now that we have one denominator, this one thing on the bottom is key here, just one thing here, we can separate it into 2 parts. We can say that 1 over y is equal to x squared over x, the same thing, x squared over x plus x squared over x squared plus 1 over x squared. So you can see here that would be x squared plus 1 over x squared with the same denominator. We can just add the numerators. So that's how we separate these and get it in terms of x. We're going to get 1 over y is equal to 1 plus 1 over x squared. Remember, we want it in terms of x, so leave the 1 over x squared on its own and say that that's equal to, bringing the 1 to the left, 1 over y minus 1 over 1, I'm going to write it as. Then we're going to do the reverse. We're going to write the right hand side as a single fraction and then invert them to get x squared over 1. So 1 over x squared. This is a real key skill to have at the top end, Raj, if you want to really get good at these manipulation of formula type questions within functions. Multiply the 2 things on the bottom, the y and the 1. Cross multiply, we're going to get 1 minus y on top. So we get 1 over x squared is equal to 1 minus y over y. You can see it gets quite complicated. Invert it now, we're going to get x squared over 1, or just x squared, is equal to y over 1 minus y. So now coming over here, we can say, just I'll get rid of the 1, x squared is equal to y over 1 minus y. So x is equal to the square root of y over 1 minus y. So a lot of work involved in this question. So therefore, we say the inverse function, did they call it in the question? F. So we can just say the inverse function f minus 1 is equal to the square root of x over 1 minus x. A question like this is worth practicing because they throw these in for the top end students so they can separate that kind of top 10% from the rest, Raj. And if you're able to do this question with no hassle, you'll hopefully see yourself within that top 10%. Alright, I'm going to challenge you to do 3 graphs. I want you to graph the line y is equal to x. You don't have to do a massive range here. Let's see, minus 3. Well, we'll just do it in positive. We'll do it between, let's say, 0 and plus 3. So this is my range of values. Graph y is equal to x. Graph y is equal to 2x. And graph y is equal to, let's say, a half x, which is the same as x over 2. So I want you to challenge yourself to graph these 3 things now. Pause the video, do a good sketch in your copy, and graph these between 0 and 3. So how did you get on, Raj? Now here's how I do it. I do my x and y axis like this. I've deliberately not done the scale perfect just to show you that it's a sketch. So the graph y is equal to x will obviously come down through here. We don't need that part of it, but I think it helps when you're trying to draw a line here where the slope is equal to 1, y is equal to x. So we're going to have these points consistent on it. We'll do the same scale, just I'll get rid of these lines. You can see here 3, 3 approximate is there. If we change colors, how did you draw? I'd be interested now, Graham, when I see how you drew y is equal to 2x. We know the point 0, 0. The slope of this line is equal to 2. That could help you draw it, or you give a value. Give x is equal to 1. When x is equal to 1, y you can see is equal to 2. So really identifying that it climbs much quicker, you can just estimate the point 1, 2 there and draw your line much steeper up this way. The line y is equal to 2x. It's harder to cycle up a steeper slope, Raj. That's the way I teach you in class. And then finally y is equal to a half x. 0, 0 obviously again. And then what about when x is equal to 2? You can see 2 halves, y will be 1. So approximately there, my graph is not brilliant, but it would kind of look a bit more like this. So what I'm trying to show you here is that these inverse functions, to finish off this video, are mirror images of each other around the line y is equal to x. And we go, so look at some exam questions. You're going to see examples of this. So hopefully now, Raj, you've mastered functions and you're ready to try the exam questions. It's tough to do them all at the same time when you haven't completed calculus and things like that, but you should be able to make a good stab at them at this point.